Hey everyone, very good morning to all of you. Let me know in the comment section if I am clearly audible and visible to you. Yeah. Am I audible clearly? Good morning, good morning. Hello everyone. Yeah, welcome back to our Pyara Sa channel, and in this journey of preparing at home and starting towards our dream, few days, already what we are trying to go ahead with is, even with enjoying our vacations, we are trying to start our journey towards our very big goal, that is the NEET exam. Yeah, so I hope everyone homework completed. Very nice here, very nice. I hope everyone would have tried to do some problems which I gave you yesterday, some 3-4 bits. So how you would like to start today? And yes, today's discussion is of integration. So I think let us start with the topic of integration right now. And after learning the fundamentals of integration, I will be discussing the yesterday's homework also today. Notes have been already shared on the Telegram group. After this session or in the break time, you can just check the Telegram group. Anyone who has not joined the Telegram group, you can just click on the description of this video. You will get a link over there, and from there you can join our group. So there all the material, all the class notes, the important stuff, all the updates particularly we are going to provide. Okay, so yes, let us start with the interesting topic of integration. The way we started our beautiful journey day before yesterday, I taught you the first part of calculus, that was differentiation. And then yesterday we did some problems directly. This was the second day of our start program, and directly we started with the NEET PYQs, NEET previous year questions, even on the day second. Similarly, today I am going to teach you the fundamentals of the integration, and yes, tomorrow, the next lecture, we will be talking about the NEET previous year questions of the related to the integration. So see, on everyday basis, you are coming closer a bit towards your goal. Fine. So let us start. It is already shared in the Telegram. Yeah. What about the other subjects, sir? I think Bhanu has joined maybe today itself. So basically all the new viewers, I would like to tell you, this is a long live session on everyday basis so that you can study all the subjects in this. So first of all, I would like to start with physics. Then you will be having your chemistry lecture, then the botany, zoology, like that. So yes, we are not only teaching you one subject, rather we are trying to guide you in every subject in every possible manner, and strategy is always start from the basic, but yes, reach to the best. Okay, so let us start. So yeah, the topic today is integration. I know you are excited to discuss the homework, but yes, I would take some time. First of all, I will teach you integration fundamentals. Then before the completion of the lecture, I will discuss all the homework problems also. Okay, chaliye, let us start. So the first thing regarding the integration, I am telling you since last 2 days, I would like to repeat it once again, that whenever you talk about the delta, big change, whenever you would like to talk about the big change, and if you want to talk about the transition, so D denotes small change, delta denotes big change. D denotes small change, delta denote big change. If you want to convert the big change into small change, you make the use of differentiation. But if you want to add all small changes in order to get a big change, you will use the process of integration. So small change, I would like to change the side now. First of all, we will be having small change in differentiation, and now we want to convert the small change into big change. In last 2 days, what we are doing, we are converting the big changes into small change by differentiation. Today we are going to convert all the small changes, add small changes, and you will get a big change. So we will get the we will be using the process of integration. Okay, geometrically, but geometry, we are graphs, geometry, we are not going to discuss right now. We will just discuss when to integrate, why to integrate, and how to integrate. People feel differentiation and integration is tough. I say doing differentiation and doing integration is very, very easy. That you would have realized in the last 2 days. That yes, doing the differentiation and doing integration you will learn today. But I hope you enjoyed and you have learned how to do the differentiation very easily. Hai na? So, doing differentiation is easy, but I always emphasized on why to differentiate and when to differentiate in physics. Similarly, today we are going to emphasize more on why to integrate and when to integrate in physics. How to integrate is going to be very easy for you. So, integration is not a tough topic. Where we should use the integration, that is something you need to take care. Okay. So, geometrically for graphs, you will say differentiation gives you something, and notation also, I told you dy by dx, that is how you denote the differentiation. And integration, the symbol of integration or the notation, how to write, how do you integrate? You write it as integration. This is a sign, it looks like S, but it's not S. I'll put it like this, I'll stretch it, and I'll do it like this. So this is a sign of integration. It looks like an extended S, but yes, the meaning is not at all the same. Okay, so basically this is how you write it, this is how you denote it. Okay, so integration is denoted by integration, this sign y dx. I would like to tell you that there are two types of integration. Integration means you are adding, the process of adding up. I will say integration, I call it process of summing up. Sum up the small changes in order to get the big change. That is the process of summing up. If you know where to start the process of summing up, and if you know where to end the process of summing up, sir, we would like to add the changes from here, and we would like to add and stop. So if you know that where to start the process of addition, and if you know where to end the process of addition, you are definite, you are specific. You know where to start the integration, you know where to end the integration. So you are definite. That type of integration is called definite integration. If you are specific from where to where, that is called definite. And if you are not specific, you know the process, you know how to add up the things, but you don't know where to start and where to end. That type of integration is called indefinite integration. Naturally, they have their own uses. You can't say, sir, we are interested in definite, we are not interested in indefinite, or definite integration, when you are sure, is better in comparison to indefinite. No, we don't think like that we should be knowing everything. No, what we consider is, sometimes in physics, we would like to be specific regarding the change, so we will talk about definite integration. Sometimes in physics, we will try to have the flexibility. Then we will like to have the indefinite integration. I'll tell you about them one by one. But before that, if we are talking about integration of y dx within limits x1 to x2, then this will give you what? So basically, the differentiation gives you slope of yx curve or fx curve. Differentiation gives you slope, integration gives you area under y is equal to fx curve with x-axis within limits, see, I have applied the limit. Whatever I write below this x1, this thing is called lower limit. This thing here is called lower limit. Lower limit, where to start the process. Process starts. What is the process, sir? Process is the process of summing up. Process of summing up the changes. And what is this x2? This is the upper limit. Upper limit tells you where the process ends. Process ends. So process starts or process commences, process ends or process completes. So these are the limits. Now the area under y is equal to fx curve with x-axis within limits x initial to x final. xi means initial, xf means final. See, I am writing every single detail. I hope you are getting the idea. That's fine. It's okay. Bhanu, you may be started, and few more viewers who might be having the first day with this, it's completely fine. In your free time, you try to see the day one, you will understand it much better, but it's okay. I will explain everything once again. Let us take a fresh start. I'm saying D means small change. dt means small change in time. Delta t means big change in time. dx means small change in x. Delta x means big change in x. So whenever you are interested in small change, you will write the value d. Whenever you are interested in the big change, you will write the value delta. Now, where do we actually use that, sir? If we are interested in the instantaneous values, for instantaneous values, we are interested in the small change. For example, if someone is asking you the instantaneous acceleration, you will write it as dv by dt. But if someone is asking you the average acceleration, you will write it as delta v by delta t. So this is basically, this I will say big change is required for average values. Example, if someone is asking you average acceleration vector, that will be equal to delta v vector by delta t. Suppose someone is asking you instantaneous power, scalar, that will be dw by dt or de by dt, rate of doing work. Yesterday only you people were telling, na? Rate of doing work is called power, rate of dissipation of energy is called power. Similarly here, if someone is asking you average power, then you will say W total by T total, or you can write it as delta E by delta T. So big changes are required for the average values, small changes are required for the instantaneous values. So in physics, both the changes are required, sir. And the branch of maths that deals with the changes, we call it the calculus. Calculus has many other applications also, but calculus will be primarily used in physics for dealing with the changes. Now there are two types of calculus: differential calculus, which you call it as differentiation; integral calculus, which you call it an integration. So what I'm saying is that they have some geometrical significance also. Geometrically also they mean something. What is the meaning geometrically? I'm trying to tell. Okay? What is the meaning geometrically? That's what we are trying to learn here. I hope that is okay with you. Fine. So, sir, we want to talk about integration today. Integration means we are talking about the process of summing up the changes. If we know where to start the process, where to end the process, we call it a definite integration. What is this called? This expression is called definite integration. Definite integration. Again, dear, I am telling you, in physics, this is more important to learn: when to integrate, why to integrate, how to integrate. It's gonna be easy. We will see that today itself, how to integrate. You will like it. You'll answer in the comment section very soon. Okay? Chalo. I hope this is clear to you. Quick recap is clear. Small changes for instantaneous value, big changes for average value, small change to big change. Integration, process of summing up is called the integration. If we know where to start the process of summing up, if you know where to end the process of summing up, we call that integration as a definite integration. Graph mein and in geometry, differentiation gives you the slope, integration gives you the area. Integration gives you the area. I hope now it is clear. Tell me in the comment section, is this now clear? Whatever I have told you, is it understood now? Are you sure? No, not sure. Yes or no? Video is lagging. Okay. You also check your internet connection. I'll also check it once. Fine from our side, sir. That's fine here. That's fine. Yeah, please take a screenshot. Take the screenshot, dear. Screenshot taken. Nice. Chalo. Let's move ahead. Now we are talking about, so I'll sum it up once again in a while. Before that, now we are moving about the definite and indefinite integration, types of integration. Types of integration. So there are two types of integration. Last theoretical slide, after this we will start the formula and we will start the practice. We will start the formula, we will start the practice. Our next lecture will be just like the previous one, exactly previous year questions discussion. So in the first few days, 2-3 days of the STAR program only, you are going to deal with a lot of NEET PYQs. You have done several yesterday, homework problem will be discussed today. And then in the next lecture also, we are going to deal a lot. So types of integration. There are majorly two types of integration. Number one, definite integration. Definite integration, as the name itself suggests, that you know where to start the process, you know where to end the process. Second type of integration is called indefinite integration. Indefinite integration, you don't know where to start the process, you don't know where to end the process. Indefinite, you don't know. Definite, you know. Okay. So here the properties are, in definite integration, limits are there. Limits are there, upper limit, lower limit, lower limit, upper limit. Lower limit means where the process starts, upper limit means where the process ends. And constant of integration is not there. Constant of integration, C is not there. That is not available. Now what does it mean, sir? What is the constant of integration? We will see it in a while. But before that, indefinite integration mein, you are not specific where to start the process. You don't know where to end the process. So limits are not there. Limits are not there. And if limits are not there, then there will be a constant of integration, so that for different values of this constant, what you are saying, sir, you are calling it a constant and then you are saying different values of constant. Yes, I mean it. That once the integration has been done, you got an expression which contains C. What is the value of C? We don't know. Depending upon the conditions given by the examiner, depending upon the conditions given in the question, we will get to know the value of the C. I will tell you some examples. So just prepare your mind. Definite integration, limits are there. There is no need of term C. Indefinite integration, limits are not there. So there is a need of integration, constant of integration C. So constant of integration is there and might have different values. So depending upon different values of this constant, you will have different answers. I'll tell you how to proceed with this. For example, suppose examiner is telling you if y is equal to fx, then you remember yesterday I told you that if you write y is equal to fx, Yesterday I explained this to you in too much of detail that if you write y is equal to fx, then here y and x, these are the two variables, y as a function of x. The value of x you put according to your wish, and depending upon the value of x, y comes out. That means x is an independent variable. We put the value of x as per our mood, as per our desire. We can put it independent variable that doesn't depend on anything. But depending upon the value of x, the y comes in the picture. So that is going to be a dependent variable. Dependent variable. I repeat, y as a function of x may, x is an independent variable, whereas y is a dependent variable. And dear, I told you earlier that differentiation and integration both are defined of dependent variable with respect to independent variable. Differentiation and integration both are done of dependent with respect to independent. That means if you wanted to write it as dy by dx, here y was dependent on x. Similarly, integration mein y is dependent on x. I repeat, differentiation and integration both are done of dependent with respect to independent. Okay, dependent with respect to independent. That means here x is going to be independent variable, y is going to be dependent variable. If you write the integration, how to write the integration sign? This integration of y dx or integration of fx dx within limits, and the limit will be of independent variable. Limits are not there. These limits are always of, limits are always for independent variable. Limits are always for independent variable. I hope that is clear for you. Okay. So who is independent here? X. So who will have the limit? X. X1 to or x initial to x final. X initial to x final. Okay. So that will be equal to, suppose the answer is another function gx. Now what you are writing, sir, I will explain on the next slide. I am just writing the formula so that you understand. Suppose that is gx. Fx is the question, its integration is gx is the answer. Fx is the question, its integration gx is the answer. Suppose gx is the answer. How to write the answer? Very easy. We will see on the next slide. But suppose it is the answer. Then it will be from x initial to x final. How to put the limits, sir? Whatever is your answer is, in place of x, you put x final. Upper limit minus, wherever the x is, put xi. Lower limit. I'll repeat my words again. Suppose integration of fx dx is equal to gx. What is fx, sir? A function of x. A question for you. What is gx, sir? Another function of x. Answer for you. So if you know this is the question, if you know this is the answer, how to put the limit, sir? Put the upper limit minus put the lower limit. Put the upper limit minus put the lower limit. Okay? And no constant, nothing. Similarly, if I compare this here, if y as a function of x, then please understand, see, I am saying this time again x is an independent variable, y is a dependent variable. Integration of y dx or fx dx, integration of fx dx you will write. But see, I haven't applied any limits. There is no limit in indefinite integration. There are limits in the definite integration. It will take 5 minutes of patience. Try to understand. There is no limit in indefinite integration. There is limit of definite integration. Limits are there. You know where to start the addition, where to stop the summation. Limits are not there. You know you have to sum it up. But from where till where, we don't know. We are not definite. Then in that case, answer will be, if fx is the question, and gx is the answer, then fx question will again give you gx answer, but no limits. And if no limits, then there will be a constant of integration c. This constant of integration c I was talking about. Okay, so how to write it, sir, that way? Just put plus c. Just put plus c. That's all. And the way addition and subtraction are opposite processes, multiplication and division are opposite processes, square and square root are opposite processes. Similarly, differentiation and integration are also opposite processes. So whatever you did in the differentiation, you have to exactly do opposite to it in the integration, and the things will be easy. We are going to start now on the third slide, that is how to integrate. So the questions are when to integrate, why to integrate, how to integrate. How to integrate, people are struggling, but I am telling you that that's the easiest thing. You would have learned how to differentiate in the last 2 days very easily. Similarly, how to integrate, we will learn today, we will practice tomorrow, and we will be doing some PYQs. Okay, so let me give you, before you take the screenshot, let me give you another quick review. Types of integration, there are 2 types of integration. Indefinite integration, we know we have to sum it up, but from where till where we don't know. So limits are not there, but constant of integration will be there. Means constant question will have the same answer, but plus c every time. Definite integration mein, we know the limits, we know where to start the process, we know where to complete the process. Constant ki requirement nahi hai, no requirement of this constant, but limits are there. You have to apply lower limit, upper limit. Lower limit is the value of variable where the process starts. Upper limit is the value of independent variable where the process ends. And hence, how to put the limit? You put the upper limit minus you put the lower limit. Quickly take the screenshot, then we are moving ahead. And let me know in the comment section, have you now understood this? Yes. Yes, Danesh, value of constant depends on the rules given in the question. Absolutely correct. Absolutely correct. I will explain again. I'll sum it up once again. Values of constant is from anywhere. It can be 0, positive, negative, decimal, rational, irrational. It can be anything. Yes, well said. That depends on the conditions given in the question. Okay. So I hope you have got it. Quickly take the screenshot. Easy peasy. Yeah, very nice. Yes, yes. I'm always giving you some problems to practice. I'm starting with the problems now. But before that, I'll start with the formula. Before that, you take the screenshot, please. I hope that's done. Yes, chaliye. So what we have learned today, that integration we have to start, definite integration, indefinite integration. Integration is a process of converting the small changes into big change. Small changes are required in physics for instantaneous values. Big changes are required in physics for average values, and many other uses are also there, right? So this is just the introduction. Graphical problems and geometrical problems ke liye differentiation gives you slope, integration gives you area. That we will talk in a separate session. Then there are these 2 types of integration. I hope you understood the logic why we use the integration. Now let us start with the formula, general formula. I gave you 5-6 formula to remember in differentiation. 5-6 formula to remember in differentiation. Now I will talk about the formula for integration. If y is a function of x, then you have to tell me what is the integration of y dx or integration of fx dx. But see that I am not applying the limits. So sir, if you are not applying the limits, so what will happen? Constant of integration will come. Okay, constant of integration will come. So there are many formula. 4-5 formula I gave you for differentiation, common in physics. 4-5 formula I'll give you for integration also. Okay, so first of all, integration of x to the power n. What is the differentiation of x to the power n? What is the differentiation of x to the power n? Quickly tell me in the comment section. What is the differentiation of x to the power n? Yes, the differentiation of x to the power n is, power will be multiplied and actual power will be reduced. Power will be multiplied and actual power will be reduced. Okay. Integration may you will do opposite to it. You will increase the power by 1 and divide by the incremented power. I repeat, here you reduce the power. Differentiation may you reduce the power. Integration may you enhance the power. Differentiation may you multiply with the power. Integration may you divide with the enhanced power. Got something? Differentiation and integration are opposite processes. So you have to raise the power and you have to divide by the raised power. But story is not completed because you haven't applied the limits. So you must be applying the constant of integration C. Must be there. Okay. Again, suppose I have a constant property I am talking about. If you remember, sin x derivative was cos x. D by dx of sin x was cos x. So I will say the integration and differentiation, since they are opposite processes, cos x integration is sin x. Okay. Sin x derivative is cos x. So cos x integration will be sin x. If you remember, see, this x to the power n can be applied like this. Not valid if x is equal to minus 1. If x is equal to minus 1, that is integration of dx by x or integration of x to the power minus 1 dx will not be equal to x to the power minus 1 plus 1 by minus 1 plus 1. The reason is this will come out to be 0 and overall expression will be not defined. I repeat, what I am telling is that this is the formula applicable every time, not applicable only in one particular case. That one particular case is that when the power is going to be minus 1 or function is an inverse function in the language of physics. So if you are talking about an inverse function, don't apply this formula. And don't worry, I'll give you a separate formula. So in that case particularly, we will have a formula that 1 by x, it is log x. But story is not completed. It will be done when it is plus c. So from here you can also understand that log x derivative is 1 by x and 1 by x integration is log x. Sin x derivative is cos x and cos x integration is sin x. Don't forget plus c because limits are not there. Similarly, sin x in differentiation is cos x, so integration is done. Cos x differentiation is minus sin x. So you have to understand that minus sin x integration is cos x, or directly you can write that sin x integration will be minus cos x plus c. This c can be positive, negative, 0, anything. And I hope these things are sufficient for you. One property I would like to talk about, that the way last time I told you coefficients, numerical coefficients will come out, slip out of differentiation and integration both, here also it is going to be the same. So integration of, if I am writing k fx dx, then that should be equal to k being a numerical coefficient should come out, and that should not contribute in differentiation and integration. So here k is going to be a numerical coefficient, a constant coefficient basically, numerical coefficient. Okay, I hope you got the logic. So similarly, if you have understood this, the way day before yesterday we have learned a lot of formula for the differentiation, similarly we will be talking about the integration. Just a minute, you can try to learn the formula. Yes, yes, yes. Yeah, yeah, yeah. Right, right, right. It was n minus 1, not valid if n is equal to minus 1. Correct. That's what I said. That power should not be minus 1. है ना? If it is x, the value can be anything. X is a variable. Power should not be minus 1 because if it is minus 1 plus 1, minus 1 plus 1, so denominator will come 0. It will be not defined. It will be not defined. So what we have learned here, let me explain it to you once again. We have learned that integration of x square dx, the answer will be, power will be raised by 1, x to the power 2 plus 1 by 2 plus 1 plus c. That is, that will be x cube by 3 plus c. Similarly, if you write integration of dx by x, then that will be log x or ln x. Log x or ln x, what is the major difference between the two? We will again, why do we denote it by log x, ln x? These things we will discuss separately in logarithm. So log topic we will take separately. It is log x plus c. Similarly, what we have learned here, integration of cos x dx, that will be equal to sin x plus c. And what we have learned, that integration of sin x will be, integration of sin x dx will be minus of cos x plus c. I hope you got the idea. So basically integrating these quantities, you will get these type of formula. That's what you need to remember. And yes, today's work is you review the class notes, those will be shared in the groups, and you will be prepared with learning of all the formula. Next time when we will be meeting, we will be practicing a lot of problem based on these formula and emphasizing more on the NEET PYQs. Okay, so don't forget to join this Telegram group. The link is already attached in the description of the video. And yes, you must be sharing and propagate this to maximum of your friends, so that like you are learning sitting back at home, your friends can also get benefited. And very soon you have to, you're anyways going to join the campus and full-fledged start your journey towards your NEET goal. But before that also, try to make every day productive. So stay healthy, stay smiling. See you soon with some more PYQs. All the best. After this, you will have a break and then you will be having your chemistry lecture. Enjoy the break.
A very, very good morning to all of you. YouTube पे आ जाओ. YouTube. Very good morning, everyone. How are you? Is my voice audible? Hi, good morning, Surya, Vicky, Deepti, Namaste. Yes, hello Naru. All good? Very, very good morning. Okay, I am also very, very good, guys. So today we'll be starting with the next class, which is the third lecture. Okay. In the last two classes, we have talked about basics of mole concept and fundamentals of chemistry. Those who have joined today for the first time, this is my name, Anirudh Mehta, and you are looking at Shri Chaitanya Goshala channel. Please subscribe to the channel before we start with the class today. And for your information, I'll tell you that today I've got 2 chocolate questions with me as well. Okay, so when we are doing the questions today, 2 times you'll have chance to earn chocolate. I'll give chocolate to first 2 people who answer correctly. Okay, so I hope you guys are all excited about it. When you come back to the campus, yes, then you can avail your gift as well. But they are little difficult questions, so you have to be careful while solving them. Okay, so today we are starting with our third lecture, which is, I am writing it as Mole Brahmastra. Why Brahmastra? Because in most of the chapters this will be used. What is unitary method and how to apply the unitary method, or the basic mole formulas, how to do them, we are going to do today. So the main promise that I want to take from your guys first is that you should not write in the comment box anything for right now. Okay, for next 10 to 15 minutes, please understand the concept. After that, we'll switch on the comment box again. Okay, we'll switch on the comment box again. Whatever doubts or anything you have, afterwards you can ask me. Online, obviously, I can't give you the chocolate. So after offline, you come here, then we'll do. All right, guys, let us start. Today, first, we are going to talk about what is a mole. Okay, what is a mole? Mole is nothing but a countable quantity like other things. We say a decade of years means 10 years. We say dozen of bananas means 12 items or 12 bananas. We say a pair means 2 items together. We say a deck of cards, 52 cards together. We say a century means 100 runs together. Same way, when we are talking about number of atoms, because a very, very small quantity of element will contain crores and crores of atoms. So we can't just say pairs, we cannot say about dozens. So when we want to explain the number of atoms, we generally use the term a mole. Okay, what do we use? A mole. So what is mole? Mole is nothing but, just like a dozen means 12 items, a mole means 6 into 10 power 23 items. Where did this number come from? We will just see that. Okay. So mole means nothing but it is number of particles. How many particles? It is number of particles which are equal to number of carbon atoms in 12 grams of carbon. That is the exact meaning of mole. It is number of particles. You can write it as well. Today, full notes you have to write. So keep your notebook with you. It is number of particles which is equal to the number of carbon atoms present in 12 grams of carbon sample. Okay, you pick out 12 gram of graphite, 12 gram of diamond, whatever you take, 12 gram of any carbon sample you take. You can take fullerene, graphite, diamond, whichever carbon sample you take exactly 12 gram. In that 12 gram, how many carbon atoms are there, you find. We can easily check that, because yesterday I told you unitary method. Yesterday I also told you what is the mass of one carbon atom. Mass of one carbon atom was what? Mass of one carbon atom was 1.99 into 10 power minus 23 gram. That was the mass of one carbon atom. which was 1.99. You can almost say 2 into 10 power minus 23 gram. This was the mass of one carbon atom. I know the mass of one carbon atom. I want to find how many atoms are there in 12 gram. Okay, how many atoms are there in 12 gram carbon? This is our question. So I told you how to use the unitary method. It's basic transactions that you do in daily life. I told you, if you can buy 5 chocolates for 200 rupees, the cost of each chocolate will be how much? 40 rupees. You only told me yesterday. Same thing we are doing here. So whenever you want to use unitary method, the unknown stuff, you will keep it on right hand side. The known stuff, mass, we'll keep it on left hand side. Okay, we'll keep the mass on left, we'll keep the atoms on right. So I can use the unitary method and say that when I take 1.99 10 power minus 23 grams of carbon, in that there is only one carbon atom. Can I say this? I hope everyone is clear with this thing, that 1.9999 10 power minus 23 gram contains one atom of carbon. So 1 gram will contain how much? Unitary method. Bring this whole number at the denominator. It will contain 1 upon 1.99 10 power minus 23. These many carbon atoms. What is the meaning of mole? Mole means how many particles in 12 gram carbon. So when I know for 1 gram, how much will be there in 12 gram? Multiply this by 12. So 1 by 1.99 10 power minus 23 into 12. These many carbon atoms. We know 12 by 2 is 6. So it will be 6.02 to be very precise. 6.02. 10 power minus 23 comes up into 10 power 23. This is the number of carbon atoms present in 12 grams of carbon. This is nothing but a mole quantity. Okay, so whenever we say a mole of fans, 1 mole of fans, the ceiling fans, that means these many fans, 6 into 10 power 23 fans. When I say 1 mole of grain particles or 1 mole of dal particles, so when you take a dal, these many dal particles should be there when we consider 1 mole. Okay, so this is about 1 mole. Now remember it, what we studied just now. What is the meaning of mole? Mole is nothing but how many carbon atoms are present in 12 gram of carbon. We just proved it. This number is 6.02 into 10 power 23. For simpler calculation, you can take it as 6 into 10 power 23. No need to take the decimals. So 1 mole means nothing but 6 into 10 power 23 particles. Is the particle atom? Is the particle cation? Is the particle a molecule? Depends on 1 mole of what you are checking. If I am saying 1 mole of fans, then there will be 6 into 10 power 23 fans. If I am saying 1 mole of CO2 molecules, means there will be 6 into 10 power 23 CO2 molecules. Okay. When I am saying 1 mole of hydrogen atom, so I am saying that 6 into 10 power 23 hydrogen atoms will be there. When I am saying 1 mole of sulfate ion, then there will be 6 into 10 power 23 sulfate ions. So particle can be atom depending on what they are asking. Okay, particle can be molecule, particle can be ion, particle can be fans, particle can be anything. Okay, so this is our mole. Okay, so next we'll see. So mole is what? It is a SI system. The mole is the base quantity for substance. Just now we have studied this. 1 mole is the amount of substance that contains as many particles as there are in 12 gram of carbon, and this number we have just studied. Okay, in other words, this number is also called as Avogadro number. Avogadro's number. Okay, this is the same name of the scientist who has checked it. Avogadro's number also represented as Na. Don't write it as sodium, N small a, N big A. Okay, N big A. Guys, those of you who are talking in the chat box, I initially told you? Why 12 grams? Suhana, wait for it. So those who are writing in the chat box, kindly stop. You guys are grown up now. You are already in the 11th standard. It shows Rohan, Tanav, all your names are also there with us. Guys, please, okay, behave yourself. So when you are sitting in the class, please sit like it's a regular class which is going on. Okay, please sit like it's a regular class which is going on. All right. Whatever doubts you are having in your brain, no, just keep them with yourself for some time. Why only carbon, Sushant? I told this yesterday. Please watch the yesterday's lecture. Okay. Please, whenever you are in the class, have you done this in your 10th standard? Then when teacher is teaching you, you are just standing in between and asking something. That doesn't happen, no? It doesn't happen in the offline classes here as well. It's like a normal class only. Okay. You are not allowed to just keep on talking in between. You are supposed to keep quiet when the class is going on. At the end, I will give you time. You can ask your doubts now. Whatever doubt is there, please ask. If you have a doubt, please note it down at the back of your notebook. At the end of the class, you can post it. Or later when you join here, all your doubts anyways will be cleared. Okay. So this is the one. So Avogadro number is what? Na. Don't write it as sodium, big N, big A in the subscript. Okay. All right. Next, we are going to see what is a molar mass. Now, very important thing that you can see here is this Avogadro number that we are taking. No, this Avogadro number that we are taking, it is actually nothing but 1 upon AMU. Its value is nothing but 1 upon AMU. What do I mean by this? See, when you do 1 upon AMU, what was the value of 1 AMU in grams? The value of 1 AMU in grams was 1.67 into 10 power minus 24 grams. Yesterday we did this. Atomic mass unit 1 AMU was 1.67 into 10 power minus 24 grams. When you divide AMU by 1, so when you do 1 by 1 AMU, it will be 1 by 1.67 into 10 power minus 24. Okay, when you find out this number, see, I can write 1 as 10 by 1.67 into 10 to the power minus 24. 1 I have written as 10 into 10 power minus 1. I can write like this. Okay, just to cancel out, I have written 1 as 10 into 1 by 10. That is 1 only. So when you divide 10 by 1.6, because you know 16 6s are 96. 16 6s are 96. So this is almost going at 6 times. Almost going at 6 times. So 1.67 6 times will be 10 only. So it will be 6 into 10 power minus 1, 10 power minus 24. It will come 10 power minus 23 at the bottom. It will go up and become 10 power plus 23, which is nothing but Avogadro number. Okay, very interesting to see that Avogadro number, when you do 1 by Avogadro, you get AMU. When you do 1 by AMU, you get Avogadro. Okay, very important. So remember it. So 1 by AMU is Avogadro, or we can say 1 by Avogadro is 1 AMU. It will be used very nicely when we talk about molar mass. Okay, all right. Now, yesterday we talked about the atomic mass and molecular mass. Today we are going to talk about what is the meaning of a molar mass. What is the meaning of molar mass? So, write down. Next we are talking about molar mass. Molar mass. Let's say one banana is 10 gram. One banana is 10 gram. Then what is the dozen mass of banana? Dozen mass means mass of 12 banana. So if each banana is 10 gram, then dozen bananas will be 120 gram. So what you have done is multiplied dozen with the each banana's mass. Same way, molar mass is mass of 1 mole, or we can say mass of Avogadro number of particles. So mass of 1 mole of a substance or mass of Avogadro number of particles of a substance. This is how we define a molar mass. Now, if I know that for oxygen, okay, for oxygen, we know that atomic mass was how much? Yesterday we did 16 AMU. Atomic mass was 16 AMU, means each atom of oxygen weighs 16 AMU. Then what will be the molar mass? What will be the molar mass? Molar mass will be each one has 16 AMU multiplied by the number of particles. So each oxygen has 16 AMU multiplied by Avogadro number of particles. What is the value of AMU? Can I say AMU is 1 by Na grams? 1 by Na grams into Na. Na will cancel out. So that means it becomes 16 grams. Very important. That is how beautiful the mole concept is. Where the atomic mass of oxygen was 16 AMU and its molar mass became, for oxygen atom I am saying, not oxygen molecule, for oxygen atom, atomic mass was 16 AMU, whereas molar mass came out to be how much? 16 grams. So molar mass is nothing but same magnitude but different units. So when I say 16 gram oxygen, there are so many oxygen atoms. There are 6 into 10 power 23 oxygen atoms. But when I say 16 AMU, there is only one oxygen atom. Same way, to find the molar mass of any substance, you take its molecular mass or atomic mass, just put a gram next to it. Again, I'm saying, if my mass is 5 AMU, it's mass of just one person. If I make it 5 gram, then that will be the mass of 1 mole of me. Okay, 1 mole. So mass of one particle is defined in AMU. If mass of one particle is 20 AMU, automatically mass of 1 mole particle automatically becomes 20 grams. Okay, so in the same way, we can just mention that for other things. Other examples that you can take here are, let's say we talk about water. Water is a molecule. So its molecular mass will be 2 AMU coming from hydrogen, 16 coming from here, 18 AMU. Whereas its molar mass, see, molar mass has two different names as well. Molar mass can also be called as GAM, gram atomic mass. If we are talking about atoms, because when I convert AMU to gram, it automatically becomes molar mass. So other name of molar mass is GAM, gram atomic mass, or its another name is GMM, gram molecular mass. For molecules. So if we are talking about molecules, you can call it gram molecular mass. So H2O has gram molecular mass of 18 grams. Whereas for oxygen, gram atomic mass is 16 gram. Gram atomic mass is 16 gram. Similarly, when I talk about glucose, C6H12O6, glucose, its molecular mass is 180 AMU or 180 U. AMU can also be written as U, whereas its gram molecular mass or molar mass will be 180 grams. I hope it is clear. Now we'll start with the question. Whenever the question comes from the mole concept, 3 types of conversions can be asked. They can take you from mole to mass. They can take you from mole to volume of gas. They can take you from mole to number of particles. Simple unitary method can also be used. Today is Mole Brahmastra 1 class. I will be giving you 3 formulas. We will try to solve as many number of questions that we can using those 3 formulas. In next class will be Mole Brahmastra 2, which will be an advanced class, where in the next class, which is going to be on Monday, so that you get enough time to practice as well. On Monday, the class when I take, it will be completely on unitary method. So today I'll be asking only these three things. Moles will be given, mass will be asked, mass will be given, particles will be asked, volume will be given, mole will be asked, volume may be given, particles may be asked. These type of questions we'll do today. They are simple, basic. With the formula you can do. In the next class, we are going to go for advanced questions, where I can give you that these many electrons are present in sodium sulfate, then what is the mass of sodium sulfate? Instead of going to particles, we'll go to electrons, we'll go to neutrons, okay, we'll go to charges, that charge on 7 milligram of nitride is how many coulombs, like that. So that will be advanced class, next class. Before going for the next class, today we'll do basics, okay. These three types of questions we have to deal with today. Let us start. Okay, these are the interconversion formulas. Only for today's class, please use this formula. From the next time, whenever you get a mole question, kindly do it by unitary method. That are the best methods which are there. Unitary method, nothing can be better than that. Nothing in this world can be better than unitary method when it comes to any of the chemistry question. Okay, all right. The formulas are, this flowchart you can make, or I will make this flowchart for you so that you can understand. If moles are given to you, and you want to go towards either number of particles or mass or volume. Moles, you can go to number of particles. From moles, you can go to volume of gas at STP. What is STP? Standard temperature pressure. STP is 0 degree Celsius, 1 atm pressure. In the gaseous state chapter, you will understand why this number is coming here and why STP we are putting, not the thing to be discussed right now. From moles, you can go to mass of the substance. Okay, it's very simple. We know that 1 mole of CO2 is 44 gram. 1 mole of CO2, 44 gram. Then 2 mole of CO2 is what? Double, 88 gram. So when moles are given, you want to go to mass, you multiply by molar mass. 2 moles are how much mass? 2 times 44. 2 moles CO2 is how much mass? 2 times 44. So whenever you want to go somewhere, multiply with something. So when you want to go from moles to mass, multiply by molar mass. Whenever you want to go from moles to particle, multiply by Avogadro number. Basic. Multiply by Avogadro number. If I say 1 mole of carbon is how many atoms? You say 6 into 10 per 23. So what you have done? 1 mole into Na. 5 moles of carbon are how many atoms? 5 Na. 5 multiplied by Na. Like that. Okay. Now comes moles to volume. So please remember, each mole of any gas, any ideal gas, occupied 22.4 liter at STP. This is something which will be coming from the ideal gas equation, PV equal to nRT. Okay, not required right now. You remember this value, 22.4 liter. Any gas occupies 22.4 liter when we take 1 mole. Okay, so moles into 22.4 liter becomes volume. And when you want to go opposite, just divide. Particles are given, you want to find moles, divide by Na. Volume is given, you want to go to moles, divide by 22.4. Mass is given, you want to go to moles, divide by molar mass. Simple. Divide by molar mass. Okay. If mass is given, you want to reach to moles, divide by molar mass. Now you can go from any one place to another place. If you want to go from mass to volume, like this you have to travel. Like this you will have to travel from here to here, here to here. How will you travel? First you will divide by molar mass, then you will multiply by 22.4 liter. Simple. Today every question will be done from this flow chart. Okay, because these are simple questions I am giving today. Mass to volume, volume to particles, particles to moles, moles to volume, like that. If you want to go from something like particles to mass, so first you will divide by Na, then you will multiply by molar mass. Like this you will go. Okay, so remember these three things. Whenever you want to go from moles, you multiply. Whenever you want to come to moles, you divide. Okay, so the three formulas that we get for mole is this. Three formulas we have just studied. number of moles, I'm writing it as N. N means moles. Can be written as given weight by molar mass. Can be written as given weight by molar mass. So when you have the weight, you want to go to moles, you divide by molar mass. Weight by molar mass is moles. Weight by molar mass is moles. Or moles can be written as given volume by 22.4 liter. When we are going like this, volume by 22.4 liter. So given volume by molar volume. We call it as molar volume. Okay. Or if particles are given, then moles are given particles by Avogadro number. Given particles by Avogadro number we have to divide. Then we can reach to moles. So there are three ways to reach to moles. Mass by molar mass, mass by molar mass, volume by 22.4, given particles by Avogadro particles. Okay. All right. Now let us start with the question. Quickly we will do. We have to be very quick now. We have, how much time is left? We have 18 minutes remaining. In 18 minutes, I want that all of us should be very fast and we should be able to do at least 7 to 8 questions. I'll switch on the chat now. Please be very serious and tell me, is everything clear to all of you? Is everything clear to all of you till here? I'll switch on the chat. Just a second, let me see where the chat is. Chat switch on. Just a second. Is everything clear to all of you? Just we are switching on the chat. I'll see your messages. I was not seeing your messages till now because I had switched it off. All right. Very good. Now let us start. All of you. This is the first question for us. I want you to answer. Find the mass of 5 moles of benzene. Mass of 5 moles of benzene. Ramcharan, if anybody has a doubt, please watch the video again. Okay. It may be possible that you joined in between or something. Watch the video again. Mass of 1 mole of mass of 5 moles of benzene. I need the proper units as well, everybody. I need the proper units as well. People are mentioning 390, whether it is gram or AMU, because both options will be there. Gram or AMU. $390 grams is the correct answer, everyone. You can all see here. I want to go from mole to mass. I told you, to go from mole to anywhere, you need to multiply. So I'll multiply by molar mass. So I'll take 5 moles and then I will multiply it with molar mass. C6H6. Each carbon is 12 gram. Each carbon molar mass is 12 gram. So the molar mass of C6H6 will be 6 times 12 gram plus 6 times 1 gram, which is going to be 72 plus 6, 78 gram. So 5 multiplied by 78. So we reach to 5 times 78 mass. That is the answer. Simple. The weight of benzene comes out to be 5 times 78, which is going to be 390 grams. Not 390 AMU. If I asked you molecular mass, then you should have said AMU. Molecular. Mass of one molecule. Chinna molecule. Very small. But when I say molar mass, that so many molecules are there. Okay. So molecular mass would have been 390 AMU. But mass of 5 molecules would have been 390 AMU. 5 moles become 390 gram. Tell me for the second one, how many moles of nitrogen gas? Nitrogen gas weighs 7 milligram. How many moles of nitrogen gas weighs 7 milligram? Okay, okay, giving out. Okay. Chat. How many moles are there in 7 milligram? Okay, 7 milligram bachche, 7 milligram. 2 moles is not correct. 0.25. How many moles? All of you see here carefully. I gave 7 milligram. I didn't give 7 gram bachche. 7 milligram. 7 milligram is 7 into 10 power minus 3 grams. Weight is given. What is given? Weight is given. What I am asking? Moles I am asking. What is the formulas? Formula was moles equal to weight by molar mass. This was the formula. Weight by molar mass. This was the formula. Now, weight is given 7 milligram. When I say nitrogen gas, can you all reply to me and say, am I talking about N or I am talking about N2? What am I talking about? Tell me everyone. Am I talking about N or N2? Am I talking about N or N2? Am I talking about N or N2? N2, yes, not N. Nitrogen gas exists as N2, not this. Okay, so molar mass I should take for N2. Each nitrogen ka mass number is 14. So N2 will be 28 gram. 28 gram. So the number of moles, how many I get? I will get moles value equal to weight, which is 7 into 10 power minus 3 by 28 gram. By 28 gram. Okay. So it will come 1 by 4 into 10 power minus 3. 1 by 4 can be written as 0.25 into 10 power minus 3, or we can say 2.5 into 10 power minus 4 moles. Those who had answered 2.5 10 power minus 4 moles, clap for yourself. I can see you. Clap for yourself. You have done correct. Good. Dushyant, good. Very good. All of you, very good. This is how we can solve it. Some of you are still saying the answer as 2.5 or 0.25. Bache, I gave you milligram. See carefully, milligram. I didn't give gram, milligram. So first convert it to gram and then do. All right. This is our question. Now there is a chocolate question for you. It's a difficult question. It might take some time to understand. Try this. I am giving you 2 minutes, 3 minutes I am giving you. 3 minutes I am giving you. Try this. If anybody gives me a correct answer here, I'll provide a chocolate to you. Exact answer I need. Don't do any chats. Get the answer, then put it in the chat. Be careful. Slowly solve. No, don't have to solve it very fast. Okay? Do this. A 40 rupees chocolate I'll give, Satish, but you do the answer correct. Some answers I'm getting. Whenever I'll see a correct answer, very good, Dushyant. Dushyant gets the chocolate. Dushyant, very good. Dushyant gets the chocolate. Very good, Dushyant. Where are you from, Dushyant? Very good, Venkat Shiva Kumari Kola. Venkat Shiva. Very good. Both of you will get one chocolate. Krishna, very good. Now I'll give only 2. Cheerful astronaut, very good. Okay, so you people are giving correct answers. Some of you, 4 or 5 of you have given correct answer. Very good. Clap for yourself. It's a very good question. And all right, now we will solve it. Time is up. We'll solve it. Three is to 4 is correct. 3 is to 4 is the correct answer. Everyone who is giving 3 is to 4, it is the correct answer. Okay, how should we go about it? Let us see. 2 things are given. AB. They have given the moles of AB and they have given the weight of AB. From moles and weight, what can we do? We can find the molar mass. We can find the molar mass. We know moles are equal to weight by molar mass. So we get molar mass of AB as weight of AB, which is 1.4 gram, by moles of AB, which is 0.02. 0.02. I'm finding the molar mass of AB. So molar mass of AB comes out to be how much? It comes out to be 70 gram. 70 gram. Same way we'll do for A2B. 0.01 mole of A2B. Moles are given. Mass is given 1 gram. I will find the molar mass of A2B. So molar mass of A2B will be mass of A2B given 1 gram by the moles given 0.01, which comes 100 gram. Okay. Yes. So now, can I say that this 70 gram will contain 1A and 1B? Answer is yes. So this 70 is nothing but molar mass of A plus molar mass of B. This 70 contains 1A, 1B. Whereas this 100 contains 2A, 1B. So in 100, there are 2 A's and 1 B. 2 equations I have, 2 unknowns I have. How to solve? Subtract them. So I am subtracting them. What will happen if I subtract them? We know B is going to cancel out. A minus 2A will be minus A. 70 minus 100 will be minus 30. So A becomes 30 gram. A becomes 30 gram. Now you have the value of one unknown. Now you can put the value of A in any of the unit. Let's say, let me put it in the first one. So we have 70 equal to A plus B. So B is equal to 70 minus A, which will be 40 gram. Very, very good. So 30 gram is A mass, 40 gram is B mass. A is to B ka mass ratio is 30:40 or 3:4. I hope it is clear to everybody. I hope it is clear to everybody. It is 75, sir. What is 75, beta? Beta, what is 75? It is 70 only, no? 14 by 2 is 7. 14 by 2 is 7. Is it clear to everybody? Okay, your name is Madhuri. Okay, good Madhuri, good. Madhuri got the answer. Venkat got the answer. Venkat, so Madhuri and Dushyant, both of you need to come and collect your chocolate from me. Okay? All right. Okay. One more chocolate question is there. One more chocolate question is there. Shall we go directly to the chocolate question or do we need to solve more? Should we directly go to chocolate question? Just say in the chat box directly. Then we'll directly go to that. Little thinking one. Yes, it will be a little thinking one only. Let us see if you can do that correct. These are your homework today. Okay, you will get this file. Do these as your homework. These 5 questions are your homework. This is the chocolate question which is there. Right? Write the question, try to solve. You know, you don't have to, okay, you solve it completely. I will not give you any hint. Solve it. Satish, don't be concerned about which chocolate. You should be concerned about whether I can get the chocolate or not. (1.67) 1.67 molecules. See, molecules can never be 1.67. Molecule will either be 1, 2, 3, 4, 5, 6, 10 part something. 1.67, how will you get molecules? Molecule is a whole thing, no? How can you get fraction molecules? 6 into 10 power 21. Sir, first I told Suprita, let us see what the answer is. Okay, Dushyant is saying 1.08 10 power 24 molecules. 1.083 10 power 24 molecules. Let's see if anybody gets the correct answer. 1.67, 3.34, 6 into 10 power 21, 18, 24 molecules. Okay, now let us see if someone has got the correct answer. I've seen 2-3 answers. Vasant, (3.34). Those who are saying 3.34 into 10 power something, they might be correct. I am feeling that they are correct. 3.34 10 power 21. Vasant, yes, correct Vasant. You are going correct. You are going correct Vasant. Vasant is going correct. You are confused? No problem. Everybody is confused in this question. Not a problem. Not a problem. All of you, stop chatting. Write down in your notebook. Stop chatting. Write down a note. Write down a note. Note is only gases occupy 22.4 liter at STP. Only gases, not liquids. For liquid, I will never use the number 22.4 liter. Write that in your note. For liquid and solid, do a promise to yourself, I will never use 22.4 liter. Never, never, never. Okay. Now what is the question? Question is now simple. This is the drop of water we are talking about. They are saying how many molecules are there in the drop of water if each drop is of 0.1 ml. This drop is 0.1 ml liquid. First mistake that you could have done is you would have taken it as the volume divided by 22.4 liter, get 2 moles, multiply by Avogadro number. That is the mistake that you would have done. Okay, mistake would have been this. You would say, sir, starting with volume will go to moles, from moles will go to particles. This could have been one mistake. You could have done this. Those who have done this, please don't do it next time. You would have said volume is given 0.1 ml. From here, I will divide it by 22.4 liter. Then I will multiply by particles, Avogadro number, and I'll reach here. Don't do this because for liquids, there is no 22.4 liter in 1 mole. For liquids, how do you convert volume into mass? They will always give you density, as I have given you here. Density of water is 1 gram per ml. What is density? Density is mass per unit volume. So if this liquid drop is 0.1 ml, I can say density equal to weight by volume. 1 equal to weight of a drop by volume 0.1. So weight of the water drop comes out to be 0.1 gram. Now it's a question where you know the mass of water, you want to find particles. So you will say, sir, I will use the flow chart. From weight, I will go to moles. From moles, I will go to particles. From weight to moles, moles to particles. Remember the flow chart. Weight to moles divide by molar mass means 18 because water molar mass is 18. So first I will divide by 18. Then I will multiply by Na. So I will multiply by 6.02 10 power 23. This I will multiply with. So whatever number is there, 0.1 gram divide by 18, multiply by 6 into 10 power 23 will be the answer. 0.1 by 18 multiply by 6 into 10 power 23. That will be the answer. Okay, so answer will be this. Answer will be this. Particles will be equal to weight by molar mass into Avogadro number. Whatever I wrote in the flow chart, I've just written it as a formula. Weight divided by molar mass into Avogadro. Weight is 0.1 gram, molar mass is 18 gram into 6 into 10 power 23. 6 3s are 18. So we get 1 by 3. So can I write it as 1 into 10 power 22 by 3? Answer is yes, we can write it like this. 0.1 I've written as 10 power minus 1. So 1 by 3 is 0.33. 0.33 10 power 22, or I can say 3.3 into 10 power 21. So this chocolate goes to Vasant. Vasant or Dushyant? Who told the answer? I think Vasant told the answer. Now open the chat again. Vasant. Good, Vasant. God bless you, Vasant. Good. All of you, please be more competitive in class. Instead of talking to each other, twinkle, twinkle, little star, don't do that. Don't talk to each other. You will have a lot of time in your life after you complete your college and everything to chat with girls, chat with boys. All the time will be there. Don't do all this thing here, no? Yes, Padma, very good. Padma and Vasant, two people have told this, correct? Varshika, correct. So, did you guys enjoy this class? If yes, please put a thumbs up and we'll end this class here. If you guys enjoyed it, please put a thumbs up. Is it all clear to you? ASR, okay. Because maybe I'm not able to see all the chats. That's why I said 2-3 names which I saw initially. Okay, Ratla. Is it clear to everyone? Put a thumbs up if it is clear to everyone. Crystal clear or not? Okay. Alright, guys. So I will see you on Monday. I will send you 10 to 15 mole concept questions to do today on Telegram. Okay. So we'll meet on Monday. Bye bye and see you. Goodbye.
So, good morning, one and all. I again wish everyone good morning. I hope so everyone came back after the break. Fine. So, please respond me, is my voice is audible? Everything clear? Screen is clear? Okay, that's good. Now we are going to take our next topic of a day. Before getting into that topic, let me to recapitulate some of the points what we have discussed earlier, right? That is in our topic STEM. I hope so you have gone through that topics. So small recapitulation, small points we are going to take just to link with the today's topic. Now, answer my question, are we discussing vegetative morphology or we are discussing about reproductive morphology? Okay, fine. So still keep on responding me with your answers. Very fine that we are discussing about vegetative morphology, where we have discussed already about the root, then we have discussed about the stem. Now, next question from the stem, will it be originating from plumule or from the radical part? What is the origin of the stem, plumule or the radical? Very nice. Everyone is responding. So this is a strong interaction within a class and among the teacher and the student within this live session. Please keep on responding. Very nice. That is a plumule. So what is the origin of the stem? That is the plumule part of embryonal axis. This is the ascending axis or the portion of this main axis, which is negatively geotropic but positively phototropic, right? And we discussed various type of modifications, right? Now the modifications what we discussed, like in underground we discussed about the rhizome, we discussed about the tubers, we discussed about the corms, we discussed about the bulbs. That is underground stem modification. Subaerial we discussed runners, stolones, suckers, then we discussed about the offsets. Then aerial stem modification, we discussed regarding thorns, we discussed regarding the tendrils, then we have taken the concept of bulbils for the vegetative propagation, even the phylloclade, which is very important because some terms are very confusing. The very important, the phylloclade with the cladode, right? In phylloclade we discussed the main stem and branches both are photosynthetic, whereas in cladode the main axis remain as such like a stem, but the branches get modified like a leaf, that you call it as cladode. So keep that terms in your mind because today one word is there which is little bit again making these two concepts a little bit in confusion, but you should be very much clear first of all between the phylloclade and the cladode, what we have discussed in the stem modification. Very nice. So you know all the things, now you have revised that. Today's topic what we are going to take under the botany, that is the leaf, which is the very important vegetative organ of a plant, help in the photosynthesis. Means all food what a plant is getting, that is the main photosynthetic part, here is the leaf. Now let's talk about the journal features regarding the leaf. What are that journal features? First of all, you should know here, if we are taking their journal features, the first important one what you should know, that is origin, that where it is originating. Origin, no doubt it is on the stem, it is on the aerial part of the stem, so somewhere origin is hidden there. That will be the apical meristem. I hope so you remember yesterday we discussed about the two types of buds, right? One is a apical bud and one is a axillary bud. Apical bud is having dividing cells over there. That dividing cells you call it as a apical meristems, right? I will write all the things detail on the board, but right now the origin is slightly now little bit complex as compared to the we discussed in the root and in case of the shoot. There directly you are saying in context of the root the origin is radical, in context to the shoot the origin is the plumule. Now the general features of the leaf I am trying to give you all, but sometimes botany is like that, you learn it more by the pictures and even by the concept obviously given over there, and sometimes by the mnemonics. So this is one more tip. When you are going to learn the botany, sometimes you need the mnemonics. Mnemonics means some shortcuts to learn the things. So here to learn the general features of the leaf, one mnemonic I am writing here, that is the God's leaf, right? Where the word G stands for, that is green, right? And due to green, obviously it will be photosynthetic. Just now we have introduced this chapter based on that. And O stands for what thing? Its origin. It originates from shoot apical meristem, right? It originates from shoot apical meristem. What is shoot apical meristem? Again I am giving you here. Suppose this is the tip of the shoot. It is having the meristematic tissue. It is having meristematic tissue. Now what will happen? When it will be growing, it is leaving behind a small type of projection like a tongue which is green, and you call it as a leaf primordium. What is leaf primordium? The young stage of the leaf. Like this is the tip of the shoot. It is growing upside and leaving behind some tongue-like projections. That point actually you call it as node. But who had given rise that? Shoot apical meristem, which now leave that thing and start moving still upside. Still keep on growing, it in between keep on giving the leaf primordium, and earlier one already get matures. Then next will get mature and give rise to the leaf. So right now you should know that what is the origin of the leaf, that is the shoot apical meristem, right, which is present at the tip of the shoot. Then after that D stands for that these are dissimilar, right? All leaves in different types of plants, they are not same. They can varies when you see plant to plant, they can varies in their shape. The leaves can varies from different plant to plant, or I must say different species of the plant. Even their margin can varies, even their tip even can be blunt, can be like a arrow. So that even varies. Surface texture, when you touch the leaf, you will find the difference. They varies in that aspect. So many aspects are there which makes the leaf different from the species to species. Now even D even here stands for that leaves develops at which point it develops? It develops at the node part. I already said you, if the stem is there and where the leaf originate, that point you call it as a node. One node to next node, in between what is there? Internode. This is very important information. Many times we keep on revising this thing again and again. Node is the point where the leaf develops, but from where it originates, the origin, who is giving the birth to that leaf, that will be the shoot apical meristem, right? Now as here on its surface, what is present? Stomata. What are stomata? These are tiny pores on the surface of the leaf, which will help in the exchange of gases, right? And even during the exchange of gases, when carbon dioxide is moving in, then further the photosynthesis happen in their respective cells, right? So do remember, the surface of leaf is having the stomata, which are the tiny pores on the surface. They are mostly present on the leaf surfaces, right? Then after that, L stands for, these leaves are lateral outgrowths. They are lateral means on the sides. So they are the lateral outgrowths or lateral structures, right? And E stands for, these are expanded forms. They are thin and the expanded form, like lamina, when you see it is thin. It is not cylindrical and thick like a shoot or like a root, right? Then even A stands for how the leaves are arranged. Leaves are arranged in the acropetal manner. This is very important word. In the full bio you will learn about it. What do you mean by acropetal? Now have a look here. Suppose I am drawing a branch of a stem, right? And now what happens? The leaf, the younger one, will be at the top, whereas the mature one will be at the base. To correct that, let me to draw the smallest one here so that you can easily understand that. So smaller one will be at the tip. I mean to say the younger one is toward the tip, or you can say at the apex, whereas older one is toward the base. That arrangement, when younger things are at the tip or apex, apex means the tip, when younger at tip and older at base, such arrangement you call it as acropetal arrangement, right? And we will discuss in its structure that they are even bearing the axillary bud. A here even stands for the axillary bud here, right? So do remember here A even stands for the axillary bud. In the structure we will discuss. I hope so you remember axillary bud we discussed. It is in the angle of the stem and the leaf. We will discuss in the structure of leaf once again. Can you say me what is the other name of axillary bud? Yesterday I have taught you. Give me the response for that. What you call the axillary bud as? Another name. Very nice, lateral buds, right? So axillary bud, even you call it as a lateral buds, right? So we will discuss, it is there in the angle of this stem and in the leaf here. There the buds will be present. This you call it as axillary bud. Now what F stands for? F stands for here that these are flattened structure. Generally they are flattened. Generally they are flattened, right? Why generally flattened? Because if I take, like yesterday we discussed, the leaves in case of a panchia, or I can say cactus, is going to be sharp pointed and it is somewhat cylindrical. That I'm talking about the spines, right? I'm not talking about the phylloclade here, right? So they are like a spine. So we cannot say in that way it is flattened. So generally we can say it is flattened. And one more point to learn the botany accurately, do take care of the words in your NCERT. Generally, mostly, few, none, or most of that, or all of them. These words are very important, right? Don't put from your side the word some, all, most, or approximately. These words, wherever you find, you have to circle that word and do give the importance to that words. Are you getting that? So this is one of another trick to get into your subject more accurately. And one is this example, mnemonics will help you a lot, because these are more words, you are playing more with the words. Every time retaining so many words may be not possible. So wherever is possible, and most of the places we will try to give you these mnemonics so the things will become easier for you. So this is one plan in the botany what we will use to make the botany easier for you people, right? Now this is all about the journal characters regarding the leaf. Now we have to discuss the next topic, parts of the leaf. Can you see right now a one leaf is there in front of you, and can you say me right now what we can call this part as of the stem? What I should name, where this leaf is going to be attached? What you call this point as? Please fastly give the response. I hope so you are noting down the points parallelly even while listening to the notes, to this class notes, right? You keep on noting down on your notebooks as well. What we call this point as? Anyone? Just now we discussed the point where this leaf originate. or the development of leaf happen, that you call it as nodes. Are you getting that? So this is one node is presented over there, right, from leaf where it develops, right? Now let's check about on the next of the things, like this part, the broad, conspicuous, large part, green, photosynthetic, that part you call it as the lamina part. So what the lamina is doing, can I say lamina is showing the photosynthesis? This is the main photosynthetic part. This is the main photosynthetic part of the leaf, which is going to be thin and it is going to be flattened structure. And this structure is having the stomata on its surface, right? And when you will see this structure, you will find this part, you call it as a leaf margin, right? What do you call it as? Leaf margin. Again, I am writing here, this you call it as leaf margin, and this tip you call it as leaf apex, right? And lamina even you call it as a leaf blade. This is very important. Lamina even you call it as what thing? Leaf blade. Getting that? So here what is there? First major part we have discussed about the leaf. What is that major part? That is a lamina. Other name, what I said to you, this is a leaf blade. It is the thin flattened structure which is going to be conspicuous even. Here the word is important, conspicuous. Conspicuous means it is very clear. When you see on a tree, out of this part and rest what we are going to discuss now, this one is very clear. Looking to that only you can see this is a leaf, right? Now check on the next part. What is that? Petiole. Now what petiole is doing? First of all, its structure. Can I say it will be a long, a thin, flexible structure of the leaf, right? Now what this petiole is doing, it helps the leaf for its exposure towards sunlight. Towards what thing? Sunlight. Are you getting that? And even flutter the leaf to make the surface cool. To make the surface cool, which is good for photosynthesis, right? For photosynthesis, temperature should be slightly less. Like you are having handle on a fan, no? So you hold the handle and you flutter that fan to get the cool air around you. So that pleasant air, which is going to be fresh air, how it is going to come on the surface of the leaf? That is by fluttering of this lamina with the help of this petiole. This petiole will first of all expose that and flutter it like a fan to bring the fresh air and to make the temperature lower, which is good for the photosynthesis. So this much you should know about the petiole at this point, right? Now next is which one? Leaf base. And do remember, this is leaf base, this is not a leaf blade. This is very important point. Here I spoke the word leaf blade for lamina. Here the leaf base is what? The point, this point. Where the petiole is attached to the main stem, that you call it as a leaf base. Are you getting that? So three parts are there. One, we have discussed about the lamina. Second, we have discussed about the petiole. Third, we have discussed about the leaf base over there. Are you getting that? So you must know about all the 3 points. What are their main features and what is their structure, right? So, or even with their functions, right? So this is important. This is about the parts of leaf. Now let's talk about the topic, the venation. Why we are discussing about the venation? When you see in the leaf, you will find, right, a main vein which you call it as midrib, right? This is a midrib which is having further veins over there. This main you call it as midrib. Midrib is the main vein, which are further divided into veinlets, right? Now what happens these are further divided into further reticulations. This is reticulations, right? We will discuss later whether it is parallel or reticulate venation. We will talk it later, but right now we are discussing about the various aspects. This is a midrib. Even this level you can call it as veins, and further their distribution. I must write here this point, that veinlets, further you can take it as a classification of that, or order of division over there. This you can take it as a veins, right? I repeat this point once again. This is a main vein, further divided into what thing? Veins. The main vein you call it as midrib. The main vein you call it as midrib, and next what it divided, that you call it as veins. Veins are further divided into veinlets. Veinlets are further divided into what thing? Reticulation. Can I say this order of divisions can be there in some category of the plants? What you call that leaves, we will talk it as later. But right now you should know the lamina is supported by such a network of the veins and veinlets. Are you getting that? So this vein and veinlets, what they are doing? They are supporting, they are putting support to the plant. Can I say it provide the rigidity? What do you mean by rigidity? Like the leaf will not be going to be like flaccid like this. It is becoming rigid, stiff. They are standing like a skeletal system inside that, right? That same work they are doing here. So what these veins and veinlets are doing, they are providing rigidity. Even they are acting as a channel for transportation of what thing? For the transportation of food, even for water and minerals. They help in transportation of that thing. What thing? Veins and the veinlets. Are you getting that? So I repeat this aspect once again. Any leaf, it is having main vein, what you call as midrib. That midrib is further have branching if I am taking one of the category of type, which after that we are going to take. I repeat, midrib divided into veins, veins into veinlets, then veinlets can be further divided into reticulation. This is all, this network of veins and veinlets together help to provide the rigidity, and they are acting as a channel for the food, water and minerals, right? So if now I am talking about the types of the leaf, then I will come back on this concept once again, right? So here we are talking about the, first of all, the types of venation. To understand the difference between the reticulate venation, then we will discuss about the parallel venation based on what type of leaf we are having. Is that having reticulate venation or it is having the parallel venation? After that discussion, I will come back on this diagram. Now check on this. What is venation? Venation is the arrangement of these veins and veinlets. And put focus here, they are only talking about veins and veinlets. Here they are not talking about further reticulation, because if I am talking about further reticulation, then it will create one more category of the leaf, that is reticulate leaf, which we will discuss. So what is venation? How these veins and veinlets are arranged in the lamina of leaf, that you call it as a venation. Now let's take about the types of leaves based on the types of venation. Like first of all, types of venation. First is what? Reticulate venation. Second is what? Parallel venation. Now what is the reticulate venation? When you will take a leaf, like the way I said you earlier, it is having main, the midrib, and midrib is further divided into the veins. Veins are now further divided into the veinlets. Veinlets are further divided into reticulation. Same thing what I spoke earlier, that category of leaf comes under the reticulate venation, right? So in that aspect, like previous what I discussed with you regarding this leaf, what type of venation I have shown you here? Reticulate venation. Then what all leaves are having? All leaves are having at least midrib, at least they are having veins. whether it is a reticulate leaf or it is a going to be the parallel leaf with the parallel venation. I must say the parallel venation. So at least both are having what thing? Midrib and the veins. Veinlets can be present or absent. That depends upon what type of venation we are talking about, right? Now coming back to the venations, this venation, what I said you, reticulate venation. Let me to say you the point once again here. The main vein you call it as midrib, and its branch, what do you call it as a vein, and then it is divided into veinlets, then further it is divided into what thing? Reticulation, right? So do remember, this is the first, second order, third order of division, then is fourth, and usually it is in case of the dicots. For example, in case of the pupil leaf, you will find this thing very clearly, right? Now, what do you mean by this next one? That is the parallel venation. In parallel venation, you will find, suppose this is a leaf. Now, put a focus on this point. It should be very much clear to you people, otherwise you will make mistake to identify what is a reticulate venation and what is a parallel venation. Here there is a main vein again, which you call it as midrib. Are you getting that? And further their veins are parallel to each other. I am showing veins with the other pen color like this. What are this thing now? These are the veins. So can I say veins are parallel to each other? When the veins become parallel to each other, such type you call it as which type of venation? Parallel venation. Are you getting that? And if I am taking one more type of leaf, like outline if I will draw, right, and here is the midrib and the veins. Now sometime there is a these thing, these are the veins. Now can I say veins are parallel in both the cases here, right? So the veins must be parallel to each other. Don't say veins are parallel to midrib, because if you fix this as a definition, then this will be wrong. But that's sure they don't have this reticulation like reticulate venation. I hope so. This is clear to everyone. This is in case of the, for example, like in grasses, you will find that. And this, for example, in case of banana leaf, you will find such type of the veins. Right? So observe the nature in your surrounding. These are the common plants. I am giving you the example from the very common plants which you can easily find in your nature. Right? So the midrib is common in both, but veins should be parallel to each other. But they don't have further this reticulation like this reticulate venation containing leaves are having over there. Right? So this is about the venation. I think so you should know about this much. And do remember, like reticulate is usually common in case of the dicots or generally common in dicots. Likewise, parallel venation is mostly in case of the monocots. Now, why the word mostly and generally usually? Because some exceptions are there. Bio is not a thing which is like a formula you fix to everywhere. They are having the exception as well. So exceptions we will discuss later. Just now you should focus on the things what is generalized and mostly. I am taking that aspect only. So this is about the types of the venations. Now let's talk about the next, that is the types of the leaves. Right? Types of leaves here, that is based on incision. Right? Now based on the incision, what type of leaves we are having? That types of leaf, that is of two types. You must remember here. What is that? One is the simple leaf and another is a compound leaf. I will show you through the diagram, but first of all understand the concept. Then we will do for this, you can say, the diagram work as well. The simple leaf is what? Where this lamina, suppose this is a leaf, Can I call this part as lamina? Just now I taught you. And this you call it as margin of the leaf. Now here the margin is entire. Entire means it is running like that. Opposite here, what is the case? You will find here the lamina is having the incision like this. Here the margin is with the incision. Right? But can you see this incision is just going up to here but not touching to the midrib. And both are simple leaf. First of all, to understand the types of leaf, you should know what is incision. So incision is not touching to the midrib over there. So in both the cases, this is simple leaf. Incision is the invagination or just the cut on the margin which is not touching to the midrib, then you call it as a simple leaf. Then what is a compound leaf? In the compound leaf, what happened? The incision will start so much that it give rise to a small leaflets. Now complete this you call it as leaf, means this incision has become so much in depth that it start touching to this midrib. Now this midrib you call it as a rachis, right? That you call it as what thing? Rachis, right? And these small you call it as what thing? As the leaflets, right? So what you call these things as? Leaflets. Are you getting that? So if it is like that, now their axillary bud will be here. It will be here. Earlier I said you at the base of leaf here is a axillary bud, right? So here even it is having the axillary bud. Even it is having axillary bud. But leaflets are not having the buds. Are you getting that? Now what is a compound leaf? Another type. This is one type which you call it as pinnately compound leaf. Now some leaves are like that where the incisions are going to touch at the petiole tip. This is a petiole, this is a stem, this is tip. When it start touching to the tip of the petiole like this, at the same point, that you call it as palmately compound leaf. What do you call it as? Palmately compound leaf. Are you getting that? So it is like a palm, like a hand. It is forming like this structure, right? Pinnately compound leaf example will be neem. Palmately compound leaf will be silk cotton, one of the plant. At least concept you should know. I repeat, pinnately compound will be like that, which is touching to the common axis. What is the common axis here? That common axis here you call it as rachis, which is what thing? The midrib here. And here if it is touching to the tip of the petiole, like the palm we are having. So that structure you call it as palmately compound leaf. Now let's take it through the diagrams as per your NCERT book. So what is this one? This is a simple leaf. This is which type of leaf? Simple leaf, where the lamina is going to have margin entire. And this one is which one? Pinnately compound. And this one is which one? Palmately compound. Right? So these two categories comes under the compound leaf. Fine. So this is all about the types of the leaf. Fine. Okay. Then after that, check on the phyllotaxy. Phyllotaxy is the pattern of arrangement of the leaves on the stem or of its branch. When you will see a plant, the upper leaves are more exposed to the light as compared to lower leaves. To give light appropriately to all the leaves, they will have some specific arrangement. This is very interesting word. When you will see the word phyllotaxy here, right, you will find the two terms here. Phyllo means what thing? Leaves. Taxis means its arrangement, right? So sometime you need not to learn the term without any meaning and take a pressure. If you know the meaning of the suffix and prefixes, this is the prefix, this is a suffix, Any word is formed technically like that. It is having some meanings. So here philo stands for leaves, taxi stands for the arrangement. I think so you will not struggle to learn it. You have to consider the meaning of its suffix and prefixes, and you come to know that what it means, right? Now, phyllotaxy are of how many types? See the diagram very carefully, pictures very carefully. I hope so even this concept is going to be very much clear. Let's take the first one. Can you see this is the main axis, right? And don't think these are the leaflets now. This is complete going to be a stem where this is one leaf, this is one leaf. Can I say at its axil what is present? Bud is present. If bud is present at each leaf, that means this is complete one leaf, right? Don't say this is one complete leaf, because just now you have finished pinnately compound leaf. So this is not pinnately compound leaf. This is individually one each is a simple leaf here. But which type of phyllotaxy? Alternate type of phyllotaxy. At one node only one leaf is there, but in alternate fashion. Here this is on this side, then is opposite, then next, then next. This you call it as alternate phyllotaxy, right? Arrangement of leaf. Now what is an example to that? Example to that will be China rose or shoe flower you call it as, even in case of the mustard. These are very common in your surrounding, you will find that. Even in case of sunflower you will find. Now let's check on the next. Can you see on the one node? Now how many leaves are present? 2 leaves are present. One node, how many leaves? 2 nodes. And can you see each leaf is parallel to each other? Are you getting that? In this case, they are showing the parallel type of arrangement to each other. But I will show you one more diagram. Even here, one node, you are having 2 leaves. But right now, one pair is perpendicular to the second pair. For example, if I am showing you like one pair is like that, right? Next is even like that. That is a parallel arrangement. But one is like this, second becomes like this now. Then second become like this. Can I say one pair is perpendicular to next? This is the case, this one, right? So can I say this is having which type of arrangement right now? Perpendicular arrangement, right? So perpendicular arrangement. But in both the cases, one node is having how many leaves? It is having 2 leaves. That's why you call it as which type of phyllotaxy? Opposite type of phyllotaxy, because at one node, 2 leaves are opposite to each other, right? And what is this case? This is in case of guava, and this is in case of the calotropis. You will find in the field areas or in a abandoned land, you will find this plant very commonly. You will observe there that you will find at one node 2 leaves but perpendicular to each other, right? Now your question you are asking, there in monocots you are having the type of palmately compound leaf usually, but not always we can go with that concept, right? Fine. Then after this, perpendicular to each other, right? Just now I said you this is perpendicular to each other in case of the calotropis. Are you getting that? Then after this, opposite type of phyllotaxy, one more is there. What is that? This is at one point many leaves are going to be arranged. At one point many leaves are arranged. That type of phyllotaxy you call it as which type? Whorled type. Are you getting that? See, so many examples are there. Difference between node and axillary bud. Okay, I am explaining you the difference between node and axillary bud, but let me to complete this point first of all. One node is having more than one leaves. This you call it as whorled type. Whorled type, for example, here will be Allistonia. That will be the example here, right? Now you asked me the difference between axillary bud and the node. See here, when the leaf, it is getting originated at this point of attachment of leaf. This you call it as what thing? Node. Axillary bud are some meristematic cells. This is axillary bud, which is present at the angle of the main stem and of the petiole, right? That you call it as what thing? Axillary bud, which further will divide and give rise to the branch. that you call it as axillary bud. During the vegetative phase, when it gives rise to the lateral branch, that bud you call it as which bud? That is a axillary bud, right? Let me to show you from one more diagram. Earlier we had discussed, right? Let me to show you from this diagram, right? Here even we had found on this point, what is there? There is a bud. What is present over there? Bud, right? And here a leafy projection have been shown. This leaf-like structure is known as a stipule here. If you are getting confused with that point, this is a stipule which is protecting this bud now. What this bud will do? This is an axillary bud. This axillary bud will give rise to lateral branch in future, and early it is going to be protected by this stipule part. Stipule is what? Like a tongue-like small leaf which is still protecting this meristematic cell in the form of axillary bud. I hope so you get that point. Fine. So here we have to go with the next part. We were on the types of the phyllotaxy. Just now we have completed this part of the phyllotaxy. Now we are going to discuss about the next, right? That all points we have covered. Now leaf modifications. What do you mean by modifications? Just now we have discussed about phyllotaxy. Modification is regarding change in structure, change in their form, change in their functions, that you call it as leaf modification, like we have discussed in the roots and in case of stem. I repeat the thing, in the leaf, when the plant, it is not performing their primary function, or the part of the plant is not performing their primary function due to change in its structure, form or their morphology, and start doing the function other than that, that you call it as what thing? That you call it as the modifications. As we are discussing about the leaf modification, first of all you should know what is the primary function of the leaf. Can I say it will be helping in the photosynthesis process, and even it is helping in the exchange of gases, right? Even it is helping in the exchange of gases, right? Okay, fine. You are writing buds are protected to the plants. Buds are to give rise to the branch, and to protect that initial stage of that, it is covered by the stipule part, right? Stipule is small leafy projection at the base of this petiole, where leaf base is there. It is coming from there, right? Even respiration. Respiration is what? Exchange of gases. I am talking about the first step of the respiration here, right? Coconut leaves. Okay, we will discuss later about that, because types of leaf, what we have discussed, this is more than sufficient to go with that. It is the coconut is a monocot type. It is having the parallel venations. Are you getting that? So this is about the coconut leaf. You should know about that. Coconut comes under monocots. Nodes and the leaf base. Leaf base is what? That petiole, their base, that you call it as leaf base. And node is the point of the stem where leaf is going to be attached. Are you getting that? If I am taking this as a node from where leaf originate, this is a node point which you cannot see, but we can say this is the point, you call it as node. And here on its angle a bud is there. This is a bud which further give rise to branch. This is the difference between node and the bud, right? Transpiration, even loss of excess of water is even the function of that. Are you getting that? Difference between node and bud and leaf base. Again I repeat, this, the leaf, the petiole base, you call it as a leaf base, right? From here, what is present over there? There is a presence of bud, and on the main axis, this point you call it as what thing? Node. This is the difference between leaf base and even bud and even the node, right? Now coming to the last topic of the day about the leaf modification, let's see the first one. For this, you will find here the modification of the leaf, for example, in case of the pea. In the case of pea, the terminal leaflets. These are the leaflets of the compound leaf of the pea, which is modified into what thing? Tendrils. Are you getting that? You will find this word here, right? So example here, you must remember this is of pea. Can I say now it will be acting for the support here, right? So this is for what thing? This is for the tendrils. So leaves, instead of the photosynthesis, they will start supporting the plant due to its weak stem. This is a leaf modification, right? Because the stem is going to be the very tender and soft. So leaves get modified into the tendrils. Let's see the next one. Can you see here? The leaves actually shed off. Now their base, what I am talking about, the leaf base by which the leaf is going to be attached, this part. Right? Let me to take this point. This is what thing? Leaf base. Right? Now what is the another point? This point you call it as what thing? This point. This point is a petiole part. When the petiole becomes photosynthetic, lamina is going to be shed off. But the petiole becomes photosynthetic, expanded like a leaf. That will show the photosynthesis, and that you call it as what thing? Phyllodes. Don't confuse phyllodes with phylloclade and cladode. Yesterday we discussed. Today even in the morning we have discussed that point. Are you getting that? So phyllodes is a modification of leaf where the petiole become photosynthetic. The next is what thing? The cactus, where they are forming spines. Now what function they are showing? Can I say the function they are showing? That is for protection. Right? So here spine modification is of leaf. Example is what? Cactus. Here the example you must write for acacia. Which category? Australian acacia. This is for support. This is for photosynthesis but not lamina. Now we are discussing the petiole part of it, which is becoming photosynthetic. Now the leaves are modified into spines for protection. Right? Now check on the last two one. Here is what thing? Bulbs, that is in case of onion. Can I say they are helping in the storage of food? Leaves are modified to store the food. Yesterday we discussed bulb as the reduced stem at the base of that. Onion we have discussed under there. So it will come under both modifications. Right? Now last modification we are going to discuss in case of insectivorous plants. Now this is an example of pitcher plant. Right? Now what this pitcher plant will do? It will overcome the deficiency of nitrogen by trapping the insect. Can I say their lamina now is become pitcher shape and start trapping the insect to overcome the deficiency of nitrogen in the soil. Now there is no more function of lamina for photosynthesis, but now for capturing of insect they are performing that part. So this is the next leaf modification we have discussed, right? So these are all the modifications. With that, we done with the leaf topic today. Still, please go through the concept. Wherever you have the doubts, just mark it out. When we will meet, definitely we will interact and going to solve your doubts there, right? So this is all about today's session. Do revise the full vegetative morphology. We already completed with the root part, the stem part and the leaf part. We are done with the vegetative morphology. In our next class, we are going to start with the reproductive morphology. That's all for today. Thanks a lot, students.
Okay, so good morning everyone. Hope you started your study in the in the last class, in last two classes, in first class I said what are the different branches. Okay, what are the different branches for zoology? NCERT is enough. Okay, for zoology in last 3 to 4 years, all 50 questions are coming from NCERT only. So try to get my point. NCERT for zoology is our Bible, is our Ramayana, is our any religious book that we are keeping now. So if you want to get through NEET, you have to read NCERT for zoology. Okay, so good morning everyone. Again saying good morning. Yesterday we started hierarchy of classification, and in the hierarchy of classification I said, okay, in the hierarchy of my classification I said, what I said, that you have to remember one hierarchy. I said to go for the hierarchy of cockroach. Anyone completed the hierarchy of cockroach? Please reply. Yesterday I have given one homework. Are you remembering that homework? Are you remembering that homework? I said to write the hierarchy of cockroach, frog, and that is earthworm. Anyone written the hierarchy of frog or cockroach or earthworm? Yes, yes, you are saying yes. So please write what you have written. What you have written the hierarchy of frog. If I will say hierarchy of frog, so please send your reply on this YouTube. Whenever I am free, I will see all your chats and I will reply. Please try to solve it today itself, because again daily you will get the question when you will solve. Okay, so please try to do it. Please try to do it and send your reply on this channel. Okay, and I think soon you will get the first PPT. They will upload on channel, है ना? We are going to upload on channel, so soon you will get your first PPT. So nothing to worry. You will get kingdom, phylum, class, order, family, genus, species. Keep pond clean. Otherwise, fishes get spoiled. Yesterday someone said na, I changed. Just see, someone said na, keep pond clean. Otherwise fishes get spoiled. Getting? Yes. Someone is writing Animalia, kingdom, phylum, arthropoda, class, insecta. Yes. You are trying. Renedy. Yes. Very good. Someone, Jyoti, has written about the hierarchy of frog. So just try to do it. Today we are going to different one. Yesterday I said how many phylums we have to discuss as per NCERT. As per NCERT we have to discuss phylum. I will say as per the sequence. See towards me. Porifera, Coelenterata, Ctenophora, Platyhelminth, Aschelminth, Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata, and Chordata. Very good. They are the different phylum. Say me how many phylums? Yes, you have written the 11 phylum. Okay, that is the yes Swati, that is fishes get sick. Very good. So that is the how many phylums we have to discuss, Swati? 11 phylum. Are you getting, Swati? How many phylums are there? Jyoti, are you getting how many phylums? 11 phylums are there. Yes, Krishna 11 phylums are there. So Porifera, Cnidaria, Ctenophora, Platyhelminth, Nematoda, Annelida, Arthropoda, Mollusca, Echinodermata, Hemichordata, and Chordata. Now you have to remember one point that is very important. Are you able to give the answer of one very important question? Are you ready to reply one question? Say me yes or no. Are you ready to reply the answer of my question? Okay, very good. So what is my question? Why amoeba is not included in animal kingdom? Why the amoeba is not included in animal kingdom? My question is why amoeba is not included in animal kingdom? if you are able to reply the answer of this question, try to see. Yes, Leela Vanu. She has written the absolutely correct answer. Nikhil also written the correct answer because they are unicellular. Wonderful Leela, wonderful Nikhil. You both replied. So many are replying, but fastest finger first. That is the Leela and Nikhil. Now just see that all the animals, those who are included in kingdom Animalia, they all are multicellular. So the protozoa, it means I will say amoeba, paramecium, euglena, they are not included in the animal kingdom. So in which kingdom they are included? They are included in the animal like protista. Amoeba, paramecium, euglena, they are included in protozoa, and protozoa included in the animal like protista. So what is the character which is common in all animals without exception? What is the character which is common in all animals without character? Anyone will say, what is the character which is common in all animals without exception? That is the multicellularity. All the animals which are included here, they all are multicellular. Without exception, all are multicellular. So animal kingdom, what is the first character which is common in all animals without exception? That is the multicellularity. So although amoeba is performing some functions like animals, but as it is not multicellular, so it is not included in the animal kingdom. So this is the one point you have to remember. All animals without exception, they are having one property, that is the multicellularity. Now, how to remember the name of different phylum in a sequence? This is a big question. How to remember the name of different phylum in a sequence? Okay, so how to remember? So today I will say you have to remember the name up to the platyhelminth. Today I will say try to remember the name up to the platyhelminth. Okay, today I will say, I will not burden you, I will go very slow. Try to say, that is how to remember the name of first 4 phylum in a sequence. So you can remember like just, that is the nematoda. So what are the name of the first 5 phylum? First is the Porifera, second one is the Coelenterata Cnidaria, third is the Ctenophora where the C is silent, fourth is the Platyhelminth, and fifth is the Nematoda, that is also known as the Eschelminth. Getting now? So these are the first 5 phylum I am going to say. So today please note down the short form PCT. Please note PCT. Please note PCT. Please note. What is the short form PCT? Please note. What I say? PCT. Please note. P for Porifera, P for Porifera, C for Coelenterata Cnidaria, T for Ctenophora where the C is silent, PCT. Please, P for that is again the Platyhelminth, and that is N, note for Nematoda, that is known as the Eschelminth. Okay. So this one is the, you have to remember the name of the first 5 phylum. What is the sequence of the name of first 5 phylum? That is Porifera, Cnidaria, Ctenophora, Platyhelminth, Eschelminth. You can remember like this, that is the PCT. Please note. What is the first I said? PCT. Please note. Okay, PCT, please note. Okay, so this is the one, that what is the P for Porifera, P for Porifera, C for Cnidaria, T for Ctenophora, P for Platyhelminth, and N again for the Nematoda. Krishna has written pig cat can play nicely. Yes, that is also correct. Pig cat can play nicely. Wonderful. Okay, what he said? Pig, cat can play nicely. P for porifera here, P for porifera, C for cnidaria, C for ctenophora, P for platyhelminth, N for nematoda. Okay, so what is the ultimate target? Ultimate target is to remember the name of different phylum in a sequence. You can change. I have given you the clue. Yesterday I said na, what is the job of a faculty? To produce the spark in you. Remaining job, you are full young blood, so that you are able to do all the things. So I said that you have to remember, today you have to remember the name of the first 5 phylum. What I said, like Krishna has written, pig, cat can play nicely. Okay, so what is P? P for porifera, C for cnidaria, then C for can for ctenophora, and play for platyhelminth. And what is the last one? What is the last one? Last one, that is the first lesson of +1, and that is nematoda, that is nicely. Nematoda is also known as the esculment. So first point in animal kingdom that you have to remember, I said all animals which are included in animal kingdom, that is the animal kingdom. So I started the very first phylum of your class 11 +1 syllabus, and just see, first we have to remember the name of the phylum. Today I said to remember the name of the first 5 phylum. What I said? Pig, cat can play nicely. P for porifera, pig. Okay, pig, P for porifera. Can for C for cat, pig can. Okay, play, that they can fit, pig and cat can play nicely. This is the one short form, like Krishna said. So this is the porifera, this is the coelenterata, this is the ctenophora, P for platyhelminth, and N for nematoda, that is also known as the esculment. So please note down, please say, please note down, or please write, or please reply the name of first 5 phylums in a sequence. Please reply the name of first 5 phylum in a sequence. What is the name of first 5 phylum? What is the name of first 5 phylum? Porifera, coelenterata, ctenophora, platyhelminth, nematoda, that is also known as the esculment. So pig, cat can play nicely. P for porifera, C for coelenterata, C for ctenophora, P for platyhelminth, and that is the one that is nicely. So PCT, please note, choice yours. Whatever you want to write, you can write. Whatever you want to write, you can write, but ultimately target, that is the Simran, that is you have to remember the name of the phylum in a sequence. Why they are arranged in a sequence? Why not? I will say that first today we will read porifera, tomorrow we will read arthropoda, because the hierarchy or classification of animals, it is done in the ascending order. From simpler character, we are going to discuss about the complex character. What we are doing? From simpler character, we are moving towards the complex character. That is why in animal kingdom, the last phylum is the chordata. Last, more developed, that is the vertebrata, and in vertebrata we are included in the top order. Human beings are included in the top order. So this is the one point you have to remember. PCT, please note, P for porifera, C for that coelenterata, cnidaria also known, T for ctenophora, again P for platyhelminth, please, and note for nematoda, that is known as the esculment. So I am going to start one by one about all. Say me very fast first, what is the short form? What is the short form? Just say me what is the short form, short form to remember the name of first 5 phylum. Anyone will reply? Anyone will reply what is the short form to remember the name of first 5 phylum? Are you getting this short form? What is the short form? To remember the name of first 5 phylum. PCT, please note. Yes, Jyoti, you have written absolutely correct. P for Porifera, I am saying the last time. P for Porifera. C for Coelentata. T for Ctenophora. Here the C is constant, so that I have written the Ctenophora. P for Platyhelminth and N for Nematoda. Nematoda, that is also known as the S-helminth. That is Nematoda, that is also known as the S-helminth. S-helminth. S-helminthes are, it is also known as the round one. So, today I will say about first, that is known as the Porifera. Porifera. Related with the Porifera, you have to remember the first point. You have to remember the first point. It is the first phylum which is included in the animal kingdom. So, what is the name of the first phylum which is included in the animal kingdom? That is the Porifera. Okay, don't go for a screenshot. Definitely you will get the notes. Okay, we will upload on channel, so nothing to worry. First PPT they will upload, this note also they will upload. So nothing to write, only see carefully. Porifera. What is the meaning of? Okay, first I want to say this is the first group of animals. So they are the first multicellular animals. This is the one point that we have to remember, that Porifera is the first phylum. Porifera is the first phylum which is included in the animal kingdom. They are the primitive. Primitive means very first. They are the primitive. Primitive means very first. They are the primitive first multicellular organism. It means they are made up of many cells. Okay. Before it I said that is protozoa. Protozoa not included in animal kingdom because they are unicellular. So this is the one, that is the first multicellular animals. Yes, very good, correct. That is the Yuvraj you have written. So what is the name of the phylum? The name of the phylum is the Porifera. Porifera. What is the meaning of Porifera? The meaning of Porifera means they are the pores bearing animals. Porifera means the pores bearing animals are known as the Porifera. Pores bearing animals, it is known as the Porifera. Getting? Pores bearing animals, that is known as the Porifera. So try to see towards the board. If I will try to draw one picture related with the Porifera. See carefully, need not to draw, but just see how it is looking. All the cells which are present in the Porifera, they are collected in the form of 2 layers. Please draw a very simple diagram. All the cells which are present in Porifera, they are collected in the form of 2 layers. They are collected in the form of 2 layers. And I said, what is the meaning of Porifera? They are the pores bearing animals. The meaning of Porifera, it means they are the pores bearing animals. They are the pores bearing animals, that is known as the Porifera. So, small pores which are present on the body surface. Small pores which are present on the body surface. Small pores which are present on the body surface, they are known as the osteas. Small pores which is present on the body surface, they are known as the ostia. Through which the water is entering. Into the cavity of the Porifera. And the large pore which is present at the anterior end of the body. Yes, Samran, very good. It is the ostia. And the large pore which is present at the anterior side of the body, that is known as the osculum. So, why the name of the phylum is Porifera? Hydra also does not move. So, does it come under Porifera? No. Hydra is not coming under Porifera because Hydra is capable to move beta sometime. Hydra is having tentacles. It is capable to perform the tentacular movement. Are you getting? Hydra is capable to perform the tentacular movement. So this is the one. Okay, pores bearing animals are called porifera. So small pores, please draw the rough diagram. Small pores present on the body surface, they are known as the osteas, and the big pore which is present at the anterior side of the body, that is known as the osculum. What is known as the osculum? So this is the one point that you have to remember, that porifera, they are the pores bearing animals. Small pores present on the body surface known as the ostia, through which the water enters, and just see, and again through the osculum the water is going out. In porifera, that they are having the pores, that is by the name of the phylum is the porifera. In porifera, I will come again, that just this is the one point, please draw this simple one. They are a small body surface, they are having the small pores known as the ostia, and one big pore moving upside, that is known as the osculum. So I want to say very simple, why the name of the phylum is porifera? Name of the phylum is porifera because small pores are present. Small pores are present on your body surface. Okay, and just note down that they are, and a big pore is present at the anterior side of the body, that is known as the osculum. In porifera, I said they are known as the pores bearing animals, that is why they are the porifera. Poriferans are attached to the substratum. Substratum means base. Porifera, they are attached with the substratum. Substratum means base. Now try to see towards me. There are two different terms. Okay, are you listening me carefully? There are two different terms. One is the movement and one is the locomotion. There are two different terms. One is the movement and one is the locomotion. Say me, which is performed by the poriferans. Which is performed by the poriferans, because I said they are attached to the substratum base. They are attached to the substratum base. So which is performed by the poriferan? They are performing the movement or they are performing the locomotion. Anyone will say they are performing the movement or they are performing the locomotion. Anyone will say they are performing the, yes, little star, just little star said they are capable to perform the movement. See, like a plant, it is also attached with the substratum. So it is not happening that plant on Monday, the plant is at Bijapara and it start locomotion and on Tuesday it reach to the Hyderabad. Not happening now, because plant they can show movement. They are attached with the substratum. They can move in this way. But locomotion means it is the change in the place. It is the change in the place, that is known as the locomotion. So what is the difference between locomotion and movement? Like this movement which is not resulting in the change in the place, that is known as the movement, and which is resulting in the place of the change in the place, that is known as the locomotion. Huge difference. Huge difference. Our jaw, our lower jaw is showing movement but not locomotion, because always it is fixed here. Are you getting? So that is the one point. They are attached to the substratum, because this term will come in the entire animal kingdom. So you have to remember two types of animals. One which are attached to the substratum, one which are the free moving. One which are attached with the substratum and one that are the free moving. So what are the poriferans? They are attached to the substratum. What are poriferans? They are attached to the substratum. So this is the one point you have to remember. They are attached to the substratum. That is why they are known as the sessile. They do not move. I said now they are not able to change their location. They are not able to change their location. So this is about the porifera. Now question is coming, why the members of this phylum? What is the name of the phylum? The name of the phylum is the porifera. Why the name of this porifera is also known as the sponges? why poriferans are also known as the sponges? So this is one question. Another, please note down this question. Why the members of phylum Porifera, they are known as the sponges? Because they are having the spongy appearance. The animals of phylum Porifera, they are having the spongy appearance. That is why they are known as the sponges. Okay, that is why they are known as the sponges, because they are spongy in appearance. That is why they are known as the sponges. So this is the one that you have to remember. Why they are known as the sponges? Because they are having the spongy appearance. There are different examples of Porifera. I will show you one example. Like the name of the first animal which is included in phylum Porifera, it is the cycon. Cycon. See, how to remember the diagram? It is big tree shaped. If you will see now, it is looking like big tree shaped. Cycon, big tree shaped. Okay, are you getting? It is looking like big tree shaped. It is the cycon. See, on body surface, small pores are present. These are the small pores which are present on the body surface, and osculum is present at the anterior side of the body. So are you getting? This is the first one, that is known as the cycon. Cycon is also known as the scyph. Second example of this phylum, that is the spongilla, that is known as the freshwater sponge. I have written here particular that it is known as the freshwater sponge. What is the reason why I have written it is the freshwater sponge? Because poriferans, they are living mostly in marine water. They are living mostly in marine water. They are marine water animal. But there is one exception. That is known as the spongilla. Spongilla is known as the freshwater sponge. Spongilla is known as the freshwater sponge. So poriferans are marine. They are living in the marine water. But there is one porifera, one sponge, that is known as the spongilla, that is known as the freshwater sponge. Spongilla is known as the freshwater sponge. Now, if you will see the body structure of this animal, there are small pores on the body surface. I said these small pores are known as the ostia. What they are? They are having the ostia, and they are having one very important system, that is known as the canal system. They are having one very important system, that is known as the canal system. Canal system in sponges is known as the lifeline of sponges. I will repeat the statement. Canal system in sponges, that is known as the lifeline. Yes, someone has written, Vicky, you have written it is the water current. Very good. Okay, someone has written it is the dermal ostia. Very good, because they are present on the body surface. Canal system. Yes. Just see. Canal system in sponges is known as the lifeline of sponges. Why? Because so many activities in poriferans, they are performed with the help of water current. Water is entering into the poriferans through the ostia, and it is coming out from the body through a pore, that is known as the osculum. Okay, so this is the one that you have to remember, that what I said, yes, mostly they are the marine water, but spongilla, it is the freshwater sponge. So canal system in sponges, I said this is the canal system, participating canal system. So they are having one very important system, that is known as the canal system. Canal system in sponges is known as the lifeline of sponges. Why it is known as the lifeline of sponges? Because many vital activities is performed with the help of this canal system. Another example of this porifera, just see, it is looking like gulab jamun, na? Okay, and this is the euspongia, that is known as the both sponge. Getting? It is the euspongia. So you have to remember three examples of this porifera. One is the cycon, that is known as the scypha. One cycon, scypha. Second one, that is the spongilla, that is known as the freshwater sponge. And third one, that is euspongia, that is known as the both sponge. Okay, so this is the one that you have to remember, that three examples included in the porifera. After it, there is one phylum that is known as the coelenterata. I am going to give only the basic knowledge about the topic. Detailed knowledge we will discuss when you will come to our campus. Definitely we will say the detailed knowledge. Here only basic knowledge, that what we have to read in detail. Okay, so now that next phylum, that is the coelenterata. Why they are known as the coelenterata? Because they are having one coelentron, that is known as the gastrovascular cavity. See, if I will say about the coelenterata like this, they are also diploblastic, means they are having the two layer, and they are having one cavity. This cavity is known as the gastrovascular cavity. This cavity is known as the gastrovascular cavity, and there is one difference on the anterior end of coelentrates. They are having, surrounding the mouth, they are having the tentacles. Surrounding the mouth, they are having the tentacles like structure like this. So these are the tentacles which are present surrounding the mouth. So why they are, this is the mouth, why they are known as the coelenterata? Because they are having the coelentron, gastrovascular cavity. They are known, they are having the coelentron. Yes, endoderm and ectoderm is there. Yes, Sushant, you are very much correct. You are absolutely correct that they are two layers. They are the ectoderm and they are the endoderm. So it is known as the gastrovascular cavity. Gastro means it is related with the digestion, and vascular means it is related with the circulation. Vascular means it is related with the circulation. So the cavity which is present in the coelenterata, that is known as the gastrovascular cavity, and coelentron means the gastrovascular cavity is there. Now, another name of this phylum, if you will see, coelenterata is also known as the cnidaria. Why the coelenterata is known as the cnidaria? Because on these tentacles and on body surface also, on these tentacles and on body surface also, specific cells are present. On body surface also specific cells are present. These cells are known as the cnidoblast. These cells are known as the cnidoblast. That is why name of this phylum is also cnidaria. Yes, you have written the cnidoblast. That is why the name of this phylum is the cnidaria. So why it is known as the coelenterata and why it is known as the cnidaria, that you have to remember. I said on the tentacles they are having the specific cells which are known as the cnidoblast or which are known as the cnidocytes. That is why the name of this phylum is also known as the cnidaria. So this is the one point that you have to remember. This is one representation how the cnidoblast is looking, and this cnidoblast is performing very important function like protection from the prey also. It is also protection from the predator. It is also helpful to capture the prey also. So this is one cnidoblast cell which is present on the tentacles like. If I will say, so many examples are included in phylum coelenterata. The most common example of phylum coelenterata is Hydra. Hydra. The most common example of phylum coelenterata is Hydra. Just see, that is most common example of phylum coelenterata is the Hydra, and Hydra is known as the freshwater polyp. It is known as the freshwater polyp. The most important example, that is the Hydra, and it is known as the freshwater polyp. Normally coelentrates are marine water, but it is present in the fresh water. It is polyp. Polyp means it is the asexual phase. the maximum phase of our in their life, that is the asexual. That is why they are showing the asexual phase of the life. So Hydra is known as the freshwater polyp. Hydra is known as the freshwater polyp. Polyp means it is showing mainly the asexual phase. This is one, that is the Hydra. I will show you the other examples which are included in phylum Coelenterata. See, next one, that is known as the Physalia. Physalia. Physalia is known as the Portuguese man of war. Physalia is known as the Portuguese man of war. Just see, it is looking like a soldier wearing a hat, and it is trying to hide itself with the branches of tree. So just see, it is looking like the branches of tree. It is looking like the hat. So that it is known as the Portuguese man of war. Physalia is known as the Portuguese man of war. How beautiful it is looking. It is, just see, this is the diagram, and this is the actual animals I am showing. So you are able to get it. Like in Hydra, I have shown the actual one looking like this, and this one is the diagram we used to draw, and this one is the Physalia, that is known as the Portuguese man of war. Starfish is different, beta. Okay, Kesar, starfish is different. Starfish is included in phylum Echinodermata, na? Not here, beta. Starfish, it is in phylum Echinodermata. Are you getting? So this is the another example of Coelenterata, that is the Physalia, Portuguese man of war. Sea anemone. See how beautiful it is looking. It is the Adamsia. Sea anemone. Adamsia. That is the sea anemone. Adamsia, that is known as the sea anemone. Pennatula. It is having a pen-like structure. That peduncle-like structure. That is why it is known as the sea pen. Pennatula is known as the sea pen. Pennatula is known as the sea pen. That is pennatula. That peduncle-like structure is present. That is why it is known as the pennatula. Sea pen. Gorgonia, just beautiful. It is looking like a fan. Table fan, you know. Okay, pedal fan, you know, that anti-fan. Just see, it is looking like a fan. It is looking like this. That is why it is known as the sea fan. Gorgonia is known as the sea fan. Gorgonia. Just see, I always used to show one handmade diagram, one original diagram. So you are able to get that how it is looking and how you have to draw. When you will come to campus, you have to draw this all. Now, see, this is the sea fan. Another picture I have taken related with the sea fan, that is the sea fan. Okay, sea fan, Gorgonia. Meandriana. Another example of Coelenterata, that is the Meandriana. If you will see this Meandriana, it is looking like human brain, like folds are present in the human brain. So it is also looking like the human brain. That is why Meandriana is named as the brain coral. Meandriana is named under the brain coral. It is name given Meandriana, that is the brain coral. Meandriana, that is known as the brain coral. So this is the Meandriana, that is known as the brain coral. Obelia, another example, that is the Obelia, that is known as the sea fur. See, very important example, that is the Aurelia. Aurelia. Okay, just note down, very important example, that is the Aurelia. Aurelia is known as the jellyfish. Aurelia, that is known as the jellyfish. That is known as the jellyfish, that is the Aurelia. Corallium, that is known as the precious red coral. So today I said up to the examples of Coelenterata. Okay, I said all the examples of Coelenterata. Corallium, that is the precious red coral. Aurelia, that is known as the jellyfish. Obelia, that is known as the sea fur. Meandriana, that is known as the brain coral. This is the sea fan, Gorgonia. This is the sea fan. Pennatula, that is known as the sea pen. Adamsia, that is known as the sea anemone. Physalia, that is the Portuguese man of war. Hydra, that is the freshwater polyp. So what is the homework for today? Remember all the examples of Coelenterata without failure. Tomorrow I can ask to anyone, what is the common name? Like I said, Hydra, freshwater polyp. You have to say like this. Okay, so thank you very much for peaceful listening. We will meet again and we will continue. I will continue about the Ctenophora, Platyhelminth and Aschelminth and Annelida. Okay, thank you very much. Thank you.